続きまして、ナタン・リンダー、先ほどアンコンファレンスでオーグメントリアリティーズ、インタラクティング・スー・ザ・リアリティというセッションをリードしてくれたPhD キャンディデート、プロフェッサー・パティ・メイスの下でもって仕事してますけども、彼はインダストリーでもモバイルコンピューティングが作った AR の研究を企業の研究で長くやられて非常に経験豊かです。では、ナタン。
But I think I don't have my slides. So thank you, Hiroshi. And let me just briefly introduce myself. Before joining the lab, I spent about a decade working in industry, specifically for big corporations like Samsung and Sun Microsystems. And I love to show this image as I begin this talk to share my research, because it shows very nicely how much have changed, and yet at the same time how little have changed in the way we actually use interfaces. So these devices that you see up there are very much still around. We still use keyboard and type, things that an interface that basically origins is the typewriters, and obviously the SLAM. So keep it in mind through my brief talk today. So the group I'm a member of, Fluid Interfaces, our core research is centered around the connection between digital and physical, basically. We're trying to blend the two worlds and bring them together. Specifically, my research is centered around new form factors for computing. And I realize it is a big statement. So to try and kind of dissect that, we can look at this image, which is a very straightforward trajectory or evolution of computing, right? From mainframes to tablets and mobile phones. And somewhere along the lines, we have received the blissful, ubiquitous networks that we all use today, wireless. And the question is, what's next? The one interesting things that you all can see in the devices we use today, that they're basically display-centric. So they all have some sort of a display, and we all kind of become accustomed to use them like that. And in Fluid, we like to think, what is the answer to what's next is basically the world. And that is even a bigger statement. And I'll get to that soon. But before I do, I'll just articulate a few problems along the way. One of them is nicely shown in this image, which I got special approval to take this picture from Parimaz, my professor. This is her desk. And what you're seeing here is how actually we work in the real world, which is very much not disconnected from the digital world. So physical and digital worlds are one. In the real world, we work with notes and papers and pens and devices and so on. And we kind of all focus them towards those machines we call computers or computing devices, and we try to kind of sync them. So the fact that these worlds are not disconnected basically shifts the burden of connecting them to us, the users, which is basically what you see in this picture. I like to call this image the device curation image, or the way we've all become just device curators, babysitters of devices. What I mean by that is that there's a vicious cycle, which is kind of crazy. And my background is in consumer electronics, so I personally contributed to that, where we basically design devices, sell them, and then do it all over again every 8 months or a year or 2 years. And we're in charge of syncing them, updating the software, making them talk to each other, charging them, and so on and so forth. And we carry them everywhere, basically. And we think it's great, but actually it's a lot of work, and we have to do it. But the ideas like ubiquitous computing, pervasive computing, has been around for a while, but I don't think we have fulfilled the promise yet. And so the search for a new form factor, I think, goes through some sort of a critical path. And so one part of the critical path is this image, which I think what you're seeing on your screen is actually the PC. So what I mean by that is the PC has now minimized itself into two things, a username and a password. And the argument is very simple. If you have a username and a password and we'll give you this machine, you will probably access about 80, 90% of your data and application. This I think, is increasing for normal use, right? So the cloud is very big, and this is what you're seeing here. It's growing. The other aspect is that we have this idea called augmented reality, or a set of technologies that basically mediate human senses, that's what you see on your left, with the world. And so technologies that actually support visions like that, so screens display with interaction, pop up from thin air, and all of this is sort of pseudo-science fiction, and sort of drive definition of what is the world as an interface where objects and surfaces become interactive and contextual, that they know about you. And so this is not new. This has been discussed in the lab, and obviously Professor Ishii is a big contributor to that school of thought. And people, Professor Rekimoto, who is well known in this country, has also contributed to that. And this informed my research on a project called Luminar. And this is going to be very fast, unfortunately because of the time, but I'm going to share with you about a year of prototyping. So what you'll see is a series of 6 prototypes and their use cases. And it's also a good example of how actually we work in the lab, the way we iterate quickly. So this is the first prototype of an augmented reality interface. It's also robotic, basically a bulb that is situated on this robotic arm. And with new form factors like this come new interaction techniques. So what you're seeing here is something I call dynamic multi-touch. So in fact, as soon as the interface begins to move, we can start doing many, many interesting things. So this is already, we're at prototype 3, and what you're seeing now is the heart of the system. In this version, you can kind of see the bare bone components. So we have a laser pico projector, some control electronics, a power supply, a few sensors, and a computer. And this is all being fed through an Edison socket. So literally, you can take this and screw it into a standard light fixture and get this device to work. So this is sort of the bare bone design of the new version. And today it looks like this. And here you kind of see it. The way we can kind of attach it to normal light fixtures. So all of this is great, but unfortunately not very interesting because users really don't care about technology at all. It's actually very boring to them. What they care is about things like that, which are design objects that we can recognize and get attached to. And so this is the Luxo L1, which is by now a classic. Some of you may have it on your desk. And so part of our work was to explore the design space and generate the language for this new device. And so spend a lot of time doing that, and this is our latest and greatest prototype hardware called Luminar Blackjack. Let me show you what it can do. So imagine one day that your office space looks like this, and I'm here just browsing some photos. An easy way to think about this is an iPad projected from your desk lamp, and so this is real-time video from a really small embedded computer, which is not surprising given that this is something with computing power like our iPad. But the interesting bit, I think, starts when you start exploring what this kind of form factor affords. So you're seeing combination of multi-touch and natural gesture interaction like this, or more advanced use cases that exploit the fact that this form factor is kinetic. So, and I'm using kinetic specifically and not robotic because if you guys are seeing a robot here, we failed. So this is not a robot.